Shubha Bijaya Dashami and happy Dasara to everyone. Today I am now going to discuss about similar matrix. It's very important for CSIR net gate all purpose of exam and in case of research also. So let's start the discussion about similar matrix. So first of all, what is similar matrix? In English language, similar means what? Same to same. So that means matrix will be also same. So let us consider a matrix A. A equals Aij, that means ith row, jth column, and M by N matrix, row column matrix. You know the matrix row column is represented such a way. So let us consider A equals Aij M cross N. It is a matrix. A will be similar to B such that B equals Bij M cross N when. So if A and B are similar matrix in which condition? When they are called similar matrix. So here A and B will be similar if there exist, it is a sign of there exist a non-singular matrix. There exist a non-singular matrix. There exists a non-singular matrix P. Let us consider a non-singular matrix P such that P inverse AP equals B. So then we can call A equals B, that A and B are similar matrix. Wait, before entering into this is very much important condition. Before entering into this, I'm going to discuss about the terminology non-singular. Non-singular means what? First of all, before knowing the singular matrix, you have to know the non-singular, you have to know the singular. Let us consider A is a matrix. A11, A12, A21, A22. A 2 by 2 matrix. Don't call it 2 cross 2 because in case of matrix I have noticed that some of the students call it 2 cross 2, but it is not 2 cross 2. It is mathematically incorrect word. 2 by 2 matrix. 2 rows and 2 columns. So A equals A11, A12 and A21, A22 will be singular. So A equals A11, A12 and A21 and 22. This matrix will be singular when determinant of A not equals 0. When determinant of A not equals 0 means it is non-singular, and singular means what? Singular means determinant of A equals 0. So when we can call a matrix singular matrix, so we can call a matrix singular when determinant of that matrix equals 0, and non-singular when determinant of the matrix non-zero. So it is singular matrix and it is non-singular. So now let's come to the point, the similar matrix. Similar matrix. So if there exists a matrix P which is non-singular such that there exists a matrix P which is non-singular such that P inverse AP equals B. That means inverse of the matrix P into the matrix A into the matrix P equals B. Then A and B will be similar matrix. So A and B if similar, such as I'm going to tell you something. So you know the eigenvalue. Let us consider, you have known to the matrix A, and let us consider lambda be the eigenvalue. Lambda be the eigenvalue, EV eigenvalue of the matrix A. So P I'm okay for then P is the matrix where P has eigenvalue lambda 1. So P inverse what will be the eigenvalue of P inverse? So here I am going to discuss a little property. I am going to discuss a little property of eigenvalue. If P has an eigenvalue lambda 1, then P inverse has eigenvalue lambda 1 inverse, that is 1 by lambda 1. Yes, it is a property of eigenvalue. Yeah, I'm going to discuss the main property of the eigenvalue. Why 1 by lambda 1? Because if a matrix A has eigenvalue lambda, then the matrix A to the power m, means power A to the power, how many powers of the matrix, then the eigenvalue will be lambda to the power m. Eigenvalue will be lambda to the power m. Yes, if a matrix A has eigenvalue lambda, then the matrix A to the power m has eigenvalue lambda to the power m. So according to that property, if A is a matrix which has eigenvalue lambda, or P is a matrix which has eigenvalue lambda 1, then P inverse is eigenvalue lambda 1 to the power inverse. So when matrix A and B are similar, when a matrix A and B are similar, then P inverse A, P equals B. So P inverse has eigenvalue what? 1 by lambda 1. A has eigenvalue what? Into lambda, and P has eigenvalue lambda 1. So lambda 1 cancels out. So B has eigenvalue, and let us consider B has also eigenvalue lambda. So both has same eigenvalue. So A and B are similar matrix, means both have same eigenvalue. And now I am going to discuss two property of the similar matrix. Property of similar matrix. So if A and B are similar matrix, A and B both are similar matrix, then their property is, the property of the similar matrix will be trace, first property, trace of A equals trace of B. That means if A and B are similar matrix, then their trace will be same. And what we know, what is the trace? Trace means, such as here it is a matrix, there's sum of the diagonal element. Sum of diagonal element equals what? Sum of all eigenvalues. Sum of all eigenvalues. So if A has some eigenvalues lambda 1, lambda 2, lambda 3, etc., then all the sum will be equals what? Sum of all diagonal element, that is the trace. So trace of A equals trace of B if A and B are similar matrix. And another property is determinant of A equals determinant of B if A and B are similar matrix. So that's it for today. That is it for today. In our next class or in our next lectures, we will discuss about diagonalization of matrix. So for that, you have to know, before that you have to know the similar matrix. So thank you all.